All right, ladies and gentlemen, welcome back. This is our third and final video in Chapter 8. And in this video, we are going to look at this thing called the R-squared value. Okay, so before we go back to that, let's revisit residuals for a second. So the linear model assumes that the relationship between the two variables is a perfect straight line. The residuals are the part of the data that hasn't been modeled. Okay, remember, a residual is the data minus the model, but that could also mean that if you take the modeled value plus the residual, you get the data. So residuals are the things that they're the part that isn't in the model. Okay, the residuals help us to make sense to see whether or not the model is good, right? When a regression model is appropriate, we should find nothing left behind by the residuals. We make a residual plot like we did in the previous video, and we hope to find nothing when we do that. We want to find a boring scattered graph. So here in our BK example, this is the residuals with our x and then the residuals on the y. Notice that it's very boring, right? It is scattered, no patterns. That's exactly what we want when we're looking at residuals, okay? So what we can do if we want to measure that difference, though, is look at the standard deviation of the residuals list, right? That is denoted as S sub E, right? The standard deviation of the residuals. That is going to measure how much the points spread around the regression line. So a high standard deviation in the residuals means a high spread around the line, which may mean that it's not a very good model because the residuals are very high. Okay, so we look at the residual plot, and then we can use this calculation of the standard deviation of the residuals to calculate its model. We can make a histogram of this. We should expect to see something that is unimodal and roughly symmetric. The mean of the residuals should be 0 always, right? So if we're looking at, like, for this, when we're finding this sum and making the standard deviation, we don't need to subtract the mean because the mean is 0. We can use the 68, 95, 99.7 rule to see how well the regression model describes the data. So let's take a look at this here. So here we have, again, the BK data. Over here, we have a box and whisker plot of the total fat, and it has a standard deviation of 16.4. So if I look at just the y variable here in the total fat, I can see I have a standard deviation of 16.4, a spread that looks like this. The residuals have a standard deviation of 9.2 and have a spread that look like this. Notice that the residuals have a much smaller spread than the y variables alone. If the correlation were a perfect 1.0, we would expect, and the model predicted the fat values perfectly, residuals would all be 0 and have no variation, right? We wouldn't have a box and whisker plot for the residuals if the correlation were perfect, right? If it were a perfect 1.0 correlation, you'd have 0 residuals and this wouldn't exist, okay? As it is, the correlation is 0.83. So we can see that the model residuals have less variation than fat alone, and we can determine how much of the variation is being accounted for by the model and how much is left in the residuals. So notice that we have some variation in the residuals, we have some variation in the model, we can determine an exact number about how much variation is in the model and how much variation is in the residuals. That value is the R-squared. If you square the correlation, it gives R-squared, which is the fraction of the data's variance accounted for by the model. So the variance we're seeing in the data accounted for by the model that we've created is what this R-squared value is. 1 minus R-squared then is the fraction of the original variance that's left in the residuals. So the 69% is the fraction of the variance accounted for by the model. The 31% is the variability that is left in the residuals. So 69% of the variation is in the model, 31% of the variation is in the residuals. All regression analysis include this statistic. We usually use a capital R, right? And we just call it R-squared, right? That's the name. It's the R-squared, okay? An R-squared of 0 means that none of the variance in the data is in the model. All of it is still in the residuals. So if all of the variance is in the residuals, it means it's not a fantastic model, right? An R-squared of 0 means that it's a bad model because the variance is all in the residuals. Whereas an R-squared model that is very high and close to 1 means that the variance we're seeing is accounted for in the model and not in the residuals, so therefore it's a good model. Okay, so when we're interpreting a regression model, we do need to say what the R-squared means. Traditionally, it's a statement that looks like this. Okay, the R-squared was 69%, so 69% of the variation in total fat is accounted for by variation in the protein content. You can memorize that sentence, right? And in general, you can use this sentence anywhere on your AP exam. Blank percent of the variation in, and then the blank here is y variable, whatever your y variable is. Okay, so blank percent in of the variation in total y variable is accounted for by the variation in the blank, which is x variable. Okay, so that's a stock sentence that if asked to interpret what the R-squared means, you can say blank percent of the variation in the y variable is accounted for by variation in the x variable. There will even be some multiple choice questions on there that say which of these is an appropriate way to express the R-squared, and they'll have like 5 different sentences, and the one that's framed like this is the one that is the correct answer, right? Okay, that's what we've got about R-squared. Oh, sorry. How big should the R-squared be? It's a number between 0 and 100, because remember, R is a number between -1 and 1, which means when I square it, it's going to be some kind of positive between 0 and 1. The closer it is to 100%, sort of the stronger the model is, because it means there's less variation in the residuals. The closer it is to 0, it means there's more variation in the residuals, which means not a great model. And so it gives us a really good information about how useful the regression is by looking at the scatter around the line. Okay, that's the last of what we got for talking about R-squared. For any of these videos, questions, comments, concerns, please put them in the comments, and I'll do my best to help you out. Thank you very much for watching, and have a good day.